Okay, in this video I just want to do one more example using marginal cost. In the last example, the previous video, I did an example of marginal revenue, or sorry, marginal profit. So let's, in this case, cost, we're looking at an annual inventory cost of where Q is the order size when the inventory is replenished. So an inventory cost of storing inventory is going to be a function of the order size, how much you have to store. And what we're asked to find in this problem is the change in cost when Q increases from 350 to 351. So what is the cost of that 351st order in terms of our annual inventory cost? All right, so in order to do that, we could just use marginal cost. All right, so again, marginal cost basically is the instantaneous rate of cost at a particular point. So the cost function here is not constant. It has this factor here where we're taking this 1,008,000 dividing by Q, and then adding to that 6.3 for each order. All right, so but here we're dividing this, this kind of constant here, which might be, what it costs for the space that we're storing all of our stuff in, but we're dividing it by our orders, right? Because the more orders that we store, the less it's going to cost per order. So let's take a look at how we might approach this. What we want to find is marginal cost. So that's the derivative of cost, and in this particular case, we want to find it at 350. All right? Because if we go back to our previous example here, we know that the slope of the tangent line is approximately equal to the slope of the secant line. In other words, the instantaneous rate of change, or the derivative, is approximately equal to the average rate of change over a small interval. So that's what marginal cost is. What this says is what is the instantaneous rate of change. How is cost changing right at the 350th order? Right? And we use the lower end here because we're going to use that to project what the cost of the 351st order would be. So first we're going to need to find C prime of Q. All right, but I want to rewrite this function first as 1,008,000 Q to the negative 1 plus 6.3 Q. This way I can use the power rule. So right here then, to take the derivative, I'm going to multiply by the negative 1. That gives me negative 1,008,000 Q to the negative 2. The derivative of 6.3 Q is just 6.3. I'm going to rewrite that as 1,008,000 over Q squared plus 6.3. Now I want C prime, I want the marginal cost at 350 at one particular point in time. So if I put in 350 here for Q squared, I can tell you what I'm going to end up with is negative 8.23 for this part of it, plus 6.3, and that's going to result in negative 1.93. So actually, we save a little bit money by adding a 351st order. It brings the cost down slightly. So that's the marginal cost of the 351st or the 350th order, which another way to think of it is the cost of the 351st order. So this is an estimate. All right. Let's look at what we would find exactly to see how good our estimate was. In other words, we could find the cost of storing 351 orders minus the cost of storing 350 orders in terms of our inventories. So without going through all of the computations here, we're just going to put 351 in here and here for Q. That is going to give us 5,083.09, and then minus, we're going to put in 350 for Q, right? So that's going to give me 5,085, and you'll find that difference is negative 191. So you can see that this marginal cost is a good approximation of what it actually costs for the 351st order. All right, so just then to summarize, if I have a cost function, then C prime of x is my marginal cost. If I have a revenue function, then R prime is, so this is marginal cost, this would be marginal revenue, and then if I have a profit function, then P prime is the marginal profit. So the idea here is just that by using the derivative, we have an application to these business concepts of how much we can find out how much it would cost, or how much revenue we would make. What's the revenue on the Xth item? Maybe it could be the 10th item or the 50th item, or the profit. So it gives us the instantaneous rate of change of these quantities at one particular point in terms of what we're manufacturing or selling.